The purpose of this experiment was to observe and test the theory that wave speed does not depend on the shape or size of the pulse, how the pulse was generated, or how far it has traveled, only the medium that carries the wave. We can observe this phenomenon by observing a transverse wave pulse along two attached slinkies of various linear density. In this experiment, we used two slinkies of similar diameter attached together. In order to observe wave speed, we recorded the amount of time it took for each slinky to travel a known distance of 0.762 meters. Since it took 0.11 seconds for the metal slinky to travel 0.762 meters, the wave speed is 6.927 meters per second. Since it took 0.06 seconds for the plastic slinky to travel 0.762 meters, the wave speed is 12.7 meters per second. Since the wave speed depends on the mass to length ratio, the linear density, the result is as expected. A medium with greater linear density has more inertia. This means it will respond less rapidly and will therefore move at a lower speed. It is observed that the wave's force or size does not affect the speed of the wave. This is apparent due to similar wave speeds between transverse wave results and longitudinal wave results. An analysis on the motion of the string leads to the expression that the speed of the wave is related to tension and linear density through this equation. The minute we reach the change in properties of the medium, there is a discontinuity. Whenever an incident wave encounters discontinuity, some of the wave's energy is transmitted forward and some is reflected backward. It was observed that when starting the pulse from the metal slinky side, the reflected pulse was not inverted. When the pulse is driven from a high-density medium to a low-density medium, the junction provides little resistance and the wave is essentially able to pass over with a slight snap similar to the start of the pulse. However, when starting the pulse from the plastic slinky side, the reflected pulse was inverted. When the pulse is driven from a lower density medium to a higher density medium, the higher density medium acts as a fixed boundary. The fixed boundary results in a higher amount of the wave's energy to be reflected and causes the inversion. Since energy is conserved, both the transmitted and reflected pulses have a smaller amplitude than the initial pulse.